Hi, everybody. Welcome to our Phoenix Town Hall here. It's the first one of these we're doing for a while. Really excited to kind of go through some of the updates that we have, get some Q&A from everybody in the audience, kind of get some of a discussion going as well too. And we're really excited to kind of share everything we've been working on with Phoenix. So for anyone who is not aware or has missed our social presence over the past few weeks, we have been in the midst of what we're calling Phoenix 2.0 launch week. This is something we just kind of wrapped up yesterday. But basically what we were noticing is that we had built a ton of new features in Phoenix over the past few weeks. And we wanted to make sure that we could kind of get those into the hands of as many people as possible. And we really felt like we had reached kind of a milestone of kind of features that we could get out into the world. So we wanted to kind of commemorate that, go through this Phoenix 2.0 launch week. And so as part of this town hall, we're going to kind of go through some of those updates, what that looks like, and talk about a few other things as well too. But just also want to say we're really excited to be at this point, and this is something we only could have done because of all the support from the community, all the feedback we've gotten from everybody. So thank you to everyone who has used the product, given feedback as we've gone through. But yeah, just a quick agenda. So we're going to go through some of the new releases that we put out. So we're going to kind of show you guys some demos of that. So we got some notebooks to go through to kind of give you real hands-on on what some of those look like. Talk a little bit about where we're headed in the future, kind of what our plan is for Phoenix going forward. And then we want to leave about like 20, 25 minutes as well too for Q&A. I think kind of in keeping with the town hall format, we really want to open this up to questions that we're getting from the audience. Feel free to drop them in the Q&A as we go. We can save them for the end, go as we have kind of a little bit open with the format of this as well too. Just by quick way of intro from my side, my name is John Gahuli. I'm the developer advocate here. I'm focused almost entirely on Phoenix, so I'm purely on the open source side. And so really excited to be going through some of these updates. And Aparna, I'll let you give a intro as well.
Awesome. Hey, everyone. My name is Aparna, one of the founders here at Arize, we're in product. Super excited to be able to share all the exciting launches with you all. I think we're going to have a really fun one, actually, where we dive into give you a demo of each one of these. So yeah, John, let's jump in.
Cool. Yeah, so a little bit of like level setting that we want to go through before we jump in. For anyone who caught us at Observe, these first two slides look a little familiar, but just to kind of set the stage a little bit. We looked back at the past kind of year of AI products that had come through. We were seeing some bad, some good, but I think the thing that was consistent is that developing on top of LLMs is really a difficult thing to do, and it's very hard to do well. And I think we're seeing that kind of continue as a trend. We're seeing a ton of kind of pains within the industry and within the developer community around debugging, evaluating, kind of taking things from like an MVP into actually making them more robust. And so as you look through some of the features, a lot of this is going to be around how do we improve evaluation? How do we improve our ability to kind of get things up and running quickly and get pipelines really robust and working well, so that we can kind of continue to achieve that initial mission we had at Arize of trying to make AI development easier, better, faster, kind of make the AI applications that are coming out a lot more kind of robust.
Yeah, and I think one of the big trends, you probably felt this, on the call, was last year, the whole conversation in the ecosystem was about the model, and which model was better, which one was able to do more things. I think one of the things we're really excited about for this year is this is actually the year of people using those models to build the amazing AI products. And, I know we threw there's some that were not so great and weren't so successful, and some that really, a cursor that our team's using day in, day out. But to build really amazing AI products, as we've been talking to the community and listening to you all, I think, John and I have just come away with it's actually really hard to build the good products. It's not just, picking the best model off the shelf and then you have an amazing product. There's a lot in the process, like John was going through, which is not knowing if it's actually giving good responses, how do you evaluate, and some of the pains you had on that slide, John. I think we've just been hearing from a lot of you in the community that it comes back to easy to probably get a demo working, really hard to get an actual product to get off on the road. So this is what we set out to tackle, and Phoenix, I think all the support from the community. This is a big one that a lot of the launches today, I think, are focused around solving these.
Definitely. So with all that in mind, we want to jump into some of the releases that we have within Phoenix that have hopefully helped to alleviate some of these pains. Starting with a new deployment option that we have for Phoenix, which is really kind of a cool thing for us. We've gotten to partner with the Llama Index team to offer something we're calling Llama Trace or hosted Phoenix. You'll see us kind of use both of the two terms here. But essentially what this is we've now have offered a new kind of deployment option for Phoenix that is online, persistent, still free to use, but it's something that you can access through our website. And so this is in addition to some of the other deployment options that we had before. So for those who've used Phoenix, you could always run it locally in a notebook. You could launch it on your local machine through the terminal, could do a self-hosted kind of containerized approach as well too. And so with hosted Phoenix, we're now offering this online version of it that still remains persistent. You can kind of create one through our website and then just connect to that through API keys. And so that'll allow you to really kind of get up and running when you need more persistence than just running Phoenix in a notebook gives you, but you're not going to go through the full kind of set up a Docker container and kind of create your own managed instance there. You have a new way to kind of access Phoenix. And it's something that we've put together alongside the Llama Index team. You'll see it if you're in Llama Cloud, you can access into Llama Trace. You can just access this through our website too. Still free to use, still open source. So kind of the same Phoenix that you know and have used before, but just a new way to kind of get at it and access it. So we're really excited about this as a tool to just kind of get people up and running with Phoenix very quickly. You can kind of do it just through our website, just kind of starting up an instance there.
Yeah, to go to the website today, you can sign up. And I think, you know, we just heard from folks who are trying to use it at hackathons or trying to just spin it up and just wanted something quickly to get started with Phoenix. So you don't need to worry about only having it in a collab or having to deploy it yourself now. They have a hosted option. So check it out and definitely give us your thoughts and feedback on it.
Yeah, definitely. And moving things right along, the next piece we're going to go through is we're going to go through a couple of feature releases here, and then I'm going to jump into a notebook and show you what some of the kind of code looks like for this live. First of these is data sets, which we're really excited as a way to kind of move data in and out of the platform here for a couple different use cases. So say you are already tracing your application through Phoenix and you have a bunch of trace information that you've pulled in. Data sets is one tool that you can use to kind of curate that data and turn it into something that can be used for either fine tuning or training in some other way, or just kind of export it from the platform that way. And then you can also bring data sets into the platform to run experiments. And so this is kind of where we get into some of the experimentation and evaluation flow that we want to put forward here. But say you wanted to bring in some sort of data set from, say, like download a Hugging Face data set to use as kind of your benchmark for testing your model against. You can bring that in as a data set into the platform really easily, and I'll show you what that looks like in just a couple of minutes here. But so we're excited to add in this new kind of building block here that a lot of our other features are based on and acted and sort of incorporate and work alongside. The next piece of this is experiments. So for experiments here, again, we're going to show what this looks like live in a second, but experiments is kind of the next piece on top of data sets here, where what we were seeing is that it's easy to kind of get something working initially, but then once you start trying to iterate and improve on it, you got to kind of figure out how you're measuring change in performance over time. So are you actually improving things as you iterate on the prompt, as you swap out models, as you kind of try to build up the performance of your application? Or if you've got something that's already working and then say you upgrade to a new iteration of GPT-4, for example, are you going to see a big performance degradation over time? So that's something that we saw in our own development. Sometimes when you swap out a new model, you get immediately worse performance. So we wanted to have some way to kind of show performance over time here of different kind of test cases that you can run with experiments. And so we're really excited about the kind of potential that brings to improve the kind of testing experience and the improvement experience that we have. So one more piece on experiments here, and then I'll show you guys what that looks like in a notebook. So just kind of the structure of experiments as we have them, that's basically taking in some sort of data set. So this is all your test cases, you can think of it as. So we're going to pull in all the test cases and sometimes an expected output if you want to use that for benchmarking. And then some kind of task. So this could just be running your pipeline. It could be making a query to a model. It could be some kind of task that we're going to evaluate the performance of, and then a set of evaluators. So how are we actually measuring performance? That could be things like Rouge score, that could be the length of the response, tokens used. You had people do like string matches, if you want to take it really basic. Could also be full LLM as a judge kind of evaluations, whatever we want to do in the evaluator section. And we can define each of those. And then the experiment will kind of take all the data set cases, run them through your task, get all the outputs, run them through the evaluators, and then give you that kind of nice side-by-side view that we looked at there. And so with that, I'm actually going to jump in and show what that looks like in a notebook. Aparna, if there's anything you want to add on experiments or data sets while I do that, please go for it as well.
Yeah, no, I'll just add maybe just a little bit of the reasoning we, community kind of pushed us in this direction is it's probably easier than ever to actually make a change to your application now. Swap out a prompt, swap out a model. But a lot of time we felt this ourselves too with the application. We have our own internal co-pilot that we've been building. And when GPT 4.0 came out, we swapped over the model and it broke a lot of use cases actually within our own use case. And we only found out about them when we were using the product. And so we had heard from a lot of teams, just simple, easy to make a change, prompt, model, retriever, whatever. You ship it, but then you don't find out until later that you actually broke a bunch of things downstream. And so with data sets and experiments, I think we're really trying to push a little bit more of a evaluation-driven development approach where you save off these, and the data sets, I think John's going to go through it, is like, it could be golden ones, it could be a golden data set, it could be examples you want to definitely make sure you catch and protect and fix before you go launch it. But just helps you curate a really awesome data set. Think about it like test cases that you can come back to every single experiment and verify that it doesn't break anything before you ship it. So cool. With that, go for it, John.
Yeah. So yeah, we have an example notebook here. There's a bunch of examples within our GitHub kind of going through the experiments and data sets flow. In this case, this is a summarization service that we have that's kind of pretty straightforward. We're just going to summarize articles for us, and we want to evaluate the performance of it. So we're doing our kind of normal imports to bring in the different packages we want to use. We're launching Phoenix here to start up our session. And then because we're just making calls to OpenAI for this, we're not using any other kind of instrumentation or orchestration flow. We have a default instrumenter. I'm sure some folks on the call have used this before to capture tracing. And then getting into the data set side, in this case, we're basically just going to, like for our example here, we've got the summarization service. We want to evaluate its performance as we kind of iterate on the prompt and iterate on how we're structuring it. And so we're going to pull in a data set from Hugging Face that we can use to kind of be our kind of set of examples that we're going to test against. Also comes with some expected outputs, so we can measure differences between our summarized output and the expected output. And so we're just pulling this down from Hugging Face here, and then we're creating a data set in our Phoenix instance. So we're able to just upload a data set, just takes in the data frame name, and then some input and output keys that help make us kind of correlate to the UI as well. But this is just a data frame of test cases that we're going to use for the summarization example. And so even if I just do that, actually, I'll jump over into the Phoenix instance that we have in here, and I can show you. With that, we get this data set that you'll see pop up in this new data set section within the UI. So you'll see our news article summaries here. So we'll jump in. Right after we upload this, we're just pulling 10 for this example, just to kind of keep things interesting. But this is now uploaded into our system, and we can use this to run experiments against. And so if I jump back into summarization, we'll go a little further on. And so I mentioned experiments are made up of a data set, a task, and then evaluators. So our next thing is we got to define what our task is. This is kind of just our pipeline, essentially, like what are we actually evaluating? And so for this case, we're just going to do a method here that calls to OpenAI to summarize the article. So pretty straightforward. We're passing in the prompt because that'll make some of the iteration a little bit easier as we modify that prompt. But yeah, all we're doing is just defining that. And then we're going to go on here and we're going to define what that template looks like in our first case, just our model that we're going to use. And then we define our task. And here we just run it once to make sure that we're working. But yeah, we defined our task at this point. Next step up is we're going to define our evaluators. And so in this case, we're going to use Rouge 1 scores. Could use any kind of evaluator you want. this is kind of where we're defining our evaluator methods. And so you'll see that all we're really doing here is for the region one scores, we're just calling to a package that calculates region one scores based on an output and an expected value. So because we have expected values in our data set, each of these is going to get an output and an expected value. So we could do any kind of evaluation we wanted there. We've had people do full kind of LLM as a judge calls within these evaluators. You could do, again, like string matching, you could do region one scores, you calculate precision recall of those scores, however you wanted to actually do that evaluation. In this case, we kind of care about conciseness of the summary as well too. So we're going to include number of tokens as another evaluator that we define. So we just take each of those different ones, pass them in, create a little list of evaluators. And from there, we're ready to actually run the experiment. So this is how we'd actually go through and run the experiment. We are going to pass in our data set, task, and evaluators, and then just some metadata here that lets us kind of view the experiment in the UI easily. And so if we run that, I'm gonna actually just jump over into our example here. That will give us this first kind of initial template that we use to work with. So you can see if we click into it, we get our inputs and our outputs, some initial kind of template that we use, and it's calculating our different scores. And so if I actually go back to our data set here, you'll see we're calculating our first kind of set of scores here. For Rouge 1, the closer you get to 0.5, the better. It's kind of the rule here. So as soon as if we can get to 0.5, that would be excellent. So we're going to boost this up a little bit. Our token length is a little bit long here. So we might want to go and actually modify our prompt to kind of improve things. So jumping back over to the notebook, if we go down here, let's update the prompt. In this case, we're just going to add some text to make it a little bit more concise, include only the most important information. So if we were to, again, in this, all we have to really do is just define the template, and then we're just going to redefine our task. Data set's the same, evaluators are the same. All we have to do is just update the task we're using. And then can run that experiment through here. And then running that would give us our second one here, this concise template we have. You can see with the second round, you can click into it, see the results in a little bit more detail. And we can see that there's going to be, our scores are improving a little bit. If I go back to our experiment, we've got a little fewer tokens. Our Rouge 1 scores have gone up a bit here, but maybe more we could do to improve it. So jumping back into our case, next step here could be including a kind of few shot examples to kind of give our pipeline a couple examples to work off of. So we've got some code here that's just going to pull out a sample of 5 examples from the training split of the data set that we originally pulled from Hugging Face. We'll include those in to our template. So we're redefining our template to include those examples. You can see what the full thing looks like here as we have like all the examples pulled in of articles and their summaries. And then once again, just redefine that task, call our experiment again with, again, the same data set, same evaluators. And we're then able to get our third case here, this few shot template. So you can see scores improving somewhat. I think there's a little bit more work we could do to actually improve this pipeline. But this gives you this very nice kind of easy to compare view as we go through and make any kind of updates to our model, to our pipeline, whatever it would be. And I could click into these. I can kind of view this side by side if you want to really granularly compare some of the different experiments you're running. So if you have, in our case, we have some similar kind of scores in our last 2. Maybe we want to actually dive in and go side by side, compare the few shots concise, and look at this as it increases over time. And we could click into these, see further details on them. So it gives us a really nice place to kind of see the change in performance, the change in scores through our evaluators as we iterate on prompts, models, all that kind of stuff within experiments. And yeah, as I mentioned, could change the task out. You could change the model that we're using, the prompt template. You could do pre-processing of data before it goes into the model, whatever you want it to do in that task. It all just sort of sits within the task, and then you can run it through different experiments or different tasks through the same experiment to get different side-by-side results like that. Awesome. So that's experiments and data sets. Really excited to show that. Some other kind of cool things you can do with data sets that we'll show in a second in terms of curating data within the platform. But we're really excited for the potential of experiments as we go through there.
Yeah, maybe just one more thing to highlight here is the task that John you're just highlighting. It can really be flexible. Like, I know we went through kind of like a prompt change one, but if you have one that's a task is calling a different model, or if you're swapping out retriever, if the task is a whole chain, You can totally define the task as simple as complex as you want. And then similarly on the evaluator side as well. So with the evaluators, you can use LLM as a judge, you can use code. You're not restricted to only the metrics we kind of, showed you here. So feel free to kind of bring in your own, plug in your own metrics and evaluators. So super flexible.
Yeah, definitely. And I think we're sharing some links as well in the chat if you guys have seen those too, just to some of the stuff we're talking about here. And if you look in our GitHub too, there's a bunch of examples. There's a whole folder of experiment examples. So it'll go through what this looks like for LLMs and judge approaches, for text to SQL kind of tasks, like a bunch of other examples that you can see there too. So we really tried to make it pretty flexible so that it fits within the work that you're trying to do, as opposed to like imposing some sort of structure on you guys. So this is ideally meant to kind of fit with what you are already doing and just give like a kind of nice way to visualize and wrap it around it.
Yeah, and we'd love to hear from y'all what kind of tasks and experiments you're doing. We built this with some folks in the community. They were telling us about their specific tasks and how they're doing it. So definitely drop us a note in the community Slack if you're doing something and you want to share what kind of experiments you're running.
Definitely. Awesome. So a couple other releases we want to highlight as well too, and then we'll go into some Q&A. So on the subject of evaluators and things that you can use with evaluations, another kind of evaluator that we've added into the platform is function calling evals. So you guys might have seen us put some material out around this. This is another use case that we were hearing from a lot of the community that are trying to kind of work on and measure. So I think most people are probably familiar, but just if anyone's not familiar with function calling evals, or function calling, excuse me, it's an ability that you have within some LLMs today to pass in kind of JSON definitions of functions that model might need to call to kind of resolve whatever the task is from a user or the prompt is from a user. So say you're building a chat bot for some like a e-commerce brand, you might provide in some functions that are things like check on the status of a shipping or like a package being shipped. You might provide like a function for looking up product details or something like that. And essentially the LLM will take those in and then can choose whether to call one of those. You can force it to call them, but you can also have it choose which one to call one of those, generate the actual function call, and then it will respond with that and say, hey, I think you should call this function. And then a lot of pipelines are set up nowadays to actually then go call it, get the response, kind of go on from there. What we were seeing though is that these are really powerful, but it's really hard to get them right and to evaluate them. And if you look at kind of just the flow that we have here, even just in that flow of deciding whether or not to call a function and generating the function, there's a bunch of steps that have to go right for this to work. So you have to have the decision to call a function and choose the right function be made correctly. You then say you've decided to call a function, or the model's decided to call a function. It has to pull out the right parameters in the right format from the user's prompt. So say you've got a user asking a question like, hey, my order ID is XYZ. Where's my package? When is it getting delivered? You've got to have the model know that it's an order ID in the prompt and not necessarily like a tracking or shipping number. And it's got to pull out the right value there and realize what it needs to do at that point. And so we actually were seeing that this parameter extraction step is really hard to get right because you got to get the right values, the right format. It's really tricky to do. And then say that all goes right, you then have to generate the function itself. Fortunately, models are pretty good at actually generating the code for calling these functions if they can get the parameter extraction and the decision to call the function right. But again, if you've got a model that's just performing, does kind of all of this at once, you don't really get a lot of feedback on what's happening there. So we decided to add in a new evaluator that we have to help make this process a little bit easier to debug. And that's our function calling eval. If anyone has used any of our other built-in evals, this probably looks very familiar. We're calling it function or tool calling in this case. But we basically added in a new template that can get used here to evaluate tool calling, a new kind of Rails map for that as well. And so in this case, we're just all we have to really do to use this one is we're gonna import our different values, set up this Rails map that just kind of snaps the results of our eval to a binary classification in this case. And then we can use this default method that, again, if you used evals within Phoenix, probably looks pretty familiar, to take a data frame of a bunch of results from our model. So you can just export this export these traces from Phoenix, or it could be from somewhere else. And then it will run them through this tool calling prompt template that we have. One thing that's a little unique is that we also have you passing in definitions of the tools. So just kind of similar to what would actually go into the LLM, you just pass in the JSON definition of what those tools look like, just so that we can use that to evaluate the responses. And this built-in eval will actually go through and evaluate each of those different 3 steps. So it'll say, is it routing correctly? Is it pulling the right parameters? Is it generating the right function? And so say you go through and implement this, we actually have a video walking through what this looks like. And Aparna, do you want to talk over the video, or do you want me to talk over the video?
Sure. So this is kind of a us showing the function calling eval. So in this case, it's not only evaluating, did it call the right function call or not, also has an explanation, which is super, super helpful. In this case, it says, okay, it's not this function, it should actually be another function. And the awesome thing is you can now add all of these into our data sets. So when something didn't make the right function call, you can kind of call out the ones that it messed up on, like in this case, and add it to a data set. Now you have this whole list of examples that, next time you make an iteration on your experiment, you can try to see if it actually improves the function calling evals on these data points that you want to fix. Again, it's not just did it get the function call right or wrong, but like John was also saying, even if it got the function call right, did it extract the parameters? And so you might even want to, we have another eval that's also kind of supported, which is correct and incorrect for each parameter that was extracted that you can also add onto your experiment. So check it out. I think the function calling evals is just another set in our kind of evals library.
Yeah, definitely. And yeah, on that note, just to kind of highlight, this is a existing eval list that we have as well too. We're adding in function calling, but we have a bunch of these other built-in evals if you haven't had a chance to play with them, for everything from retrieval, hallucination, code generation, summarization, SQL, all these kinds of different evals that are all built in there. And so you can kind of combine these with experiments, make them some of your evaluators within there, and can be used either on their own or with that experiments flow, depending on how deep you want to go into testing there. So really useful out of the box kind of things that hopefully make the evaluation process pretty straightforward and hopefully easy to use. And with that, I want to go through our last new kind of feature that we're highlighting as part of this launch week, which is integration we built with Guardrails AI. I think if anyone saw this news story about 6 months ago, it was kind of a fun one that came up, or fun for outsiders, probably not that fun for Chevy, but was a news story where someone was able to convince a Chevy chatbot to sell them a car for $1 by using some of these kind of jailbreaking techniques. There's been a bunch of cases of this happening. I think folks have seen them, but sort of just underscoring the importance of having something like guardrails in place. And so for those who are not familiar with guardrails and the concept here, essentially the way that these are able to work is you can take in either inputs into the model or outputs from the model, place guards around them that will protect against things like either PII being included, damaging responses, hallucinations, all kinds of different guards that you can use here. And so we've actually built an integration with Guardrails, not just to trace the kind of functioning of guards, which we'll show you guys as well, but we've also built our own kind of guard here that can use dynamic data to improve this. And so the way that we set this up to work is essentially you'll get some sort of input from a user coming into the guard detection system here with Guardrails AI. And then we have a specific guard that will actually can take examples from your own data. It'll calculate embeddings on those. So say examples of attacks that you've seen coming into your own data. It'll calculate some embeddings for those. And then as a new user input comes through, then we'll calculate the embedding of that and calculate the cosine distance between the two. And so that will give us, if it's under a certain threshold, basically if the incoming thing is similar enough to the existing examples that you have from your data, it can trip the guard. So can be used with just base examples of jailbreak prompts, and that's actually its default behavior. So if you don't have example attacks, that's fine. You can still use this guard, but it's really cool because it can kind of tune the guard to the specific attacks that you are seeing on your tool. So it's something that's dynamic. It'll improve over time as it gets more data to use here. And then this can obviously combine with bunch of other guards that Guardrails offers of protecting against like PII, frustration, hallucination, all kinds of different things there. And say one of these gets tripped, you can run through a bunch of different actions that you would actually go do. So you can block the response entirely. You can have it retry. You can go for like a default answer. So a lot of customization about how you want this to behave. But we definitely see guards as a kind of as a key part of a kind of production ready pipeline. You need something in place if you're giving user responses. You have this kind of issue of non-deterministic responses from models. And so you need something in place that can kind of protect against some of those bad responses. And we see this integration as a good way to do that. And can show a little bit about what that looks like in the platform too here. Got a notebook that we can walk through if we want as well. But you'll see clicking into this case where a guard is tripped. In this case, we have a guard that's set to just throw an error when it responds. So you can see someone's using the sorry, unexcusable edit, which is kind of a popular jailbreak technique. Stripping our guard, we can go through and we can actually, similar to the function calling eval example, we could create a data set of all these attacks that we're seeing. That could then be used to power the guard as well too, which is pretty cool. To that few shot example that I was mentioning before, could also just be a place to kind of collect some of the different behaviors that you're seeing. And then we've got a prompt that looks kind of dangerous, but actually is pretty benign, making it through our guard there. So as I mentioned, you could kind of collect all these cases because we have our guard erroring here. We can collect all these cases into a data set of all the jailbreak attempts that someone's going through, create that data set to use for whatever kinds of cases we wanted to. Yeah, and awesome. And so yeah, I can export that into different formats as well too. I have a notebook to walk through that. I might go through that kind of quickly because I want to make sure we can get to some of the other material. As I pull that up, Aparna, anything you want to add on the data sets side, or excuse me, on the guardrail side of things?
And maybe just one we're seeing in with other folks is folks ask us sometimes what's kind of the difference between when do I use guardrails versus when do I use evals. What we typically are seeing is so it's kind of the difference here is I almost like to think about it as proactive versus reactive. So evals are great if you're kind of going back and evaluating your application. You can use it during development, even in production, but you're kind of slightly more offline. You are offline versus guardrails. It's much more of a proactive. It's actually during inference when you want to make sure that a bad response is blocked. And so that's typically when we see people using guardrails is when and the cons of that is that it is going to add some inference latency to your it's actually in your inferencing path. But I think it's kind of a trade-off of you want to actually prevent them as opposed to find out about them afterward.
Yeah, that's a good point. But yeah, so just I'll quickly show what this looks like, and then obviously we can share all the notebooks and everything. That's all online for you guys to access. One thing that's just kind of fun too is actually in this example is we're actually in this example we're actually using hosted Phoenix. So I can kind of quickly show you guys, like if you wanted to connect to a hosted Phoenix instance, basically you're just defining some environment variables, and then that will repoint this notebook in this case to your hosted Phoenix instance. So didn't actually realize that we had that in this example. It's kind of a perfect example to show that this is what hosted Phoenix connection looks like. But yeah, so on the guardrail subject, continuing forward here, we have a new auto instrumenter that we've incorporated for guardrails to kind of trace all the information about guards as they're going through, have that show up in the platform. And then as we were talking about, we've also added our own guard to the kind of hub of guards that Guardrails offers. So that's the kind of few shot embedding approach that we were talking about before. You could use those separately. You don't have to use that guard to use the Guardrails integration. We can still trace everything if you use other guards. You'll see we're just going through and we're starting that instrumenter that will pull in and start capturing traces on guards as they go through. And then we're defining our guard to use here with Guardrails. So we're using that one that we had talked through. You can set it up to work on either prompts or responses. You can set it up to like what the failure mode is. Do I throw an error? Do I retry a response? Do I give a default response? And then there's some more detail in this notebook, which we can, again, share as well too. That goes through how you would add sources. So how you add those few shot examples to it here. And then in this case, we're not doing it. So it'll use default ones from an existing data set of popular jailbreak prompts. And again, you guys can go through this. I want to make sure we can get to some of the new stuff or some of the future stuff as well. We have a RAG application that's set up with Llama Index here using Polygram, very typical kind of RAG flow for a demo here. So that's what this is actually running on. And then with that pipeline set up, then you can see we're pulling in like a sample jailbreak prompt, same as the one we saw in the video that, sorry, an unexcusable etiquette prompt here. And you'll see we wrap that in a try catch just because we've gone for that error approach. I think if you wanted to do a retry or a default response, if the guard gets tripped, then you would just make the call directly. But you'll see the same kind of thing that we saw within that video here, where that gets tripped up by the guard. And then,
yeah. Oh no, I was just going to add one thing that might be interesting, folks, is as John's going through this, is why use a data set embedding guard as opposed to just LLM prompt guard. I mean, both are definitely options. We see them in the ecosystem a lot. I think the one thing for us to connect it to data sets made a lot of sense, is so that the guard can be not just static, but dynamic. So as you're adding in, like John's like finding a new example of something that was a jailbreak, you can add it into the data set. And then now the data set grows the number of examples, and it kind of becomes more dynamic as opposed to just like a static prompt that you have to go back and kind of keep updating. So it's kind of a cool way to think about your guard as also changing with the data that you're seeing.
Definitely. Yeah, the dynamic nature of it and the ability to kind of go back, it makes it like a kind of organic, ever improving kind of flow, which we really think is pretty cool. Yeah, we'll share this notebook. There's a couple other prompt examples showing you it working on other prompts. And then there's actually a cool example down here of showing how you could actually programmatically create a data set out of this. So all that you could do within the UI, you can also do through just our SDK here. So you can create data sets in a couple different ways. Awesome. With that, I want to move things over to, skip ahead of the video, talk a little bit about where we're headed, and then we're going to open things up for Q&A. So Phoenix, in terms of how we think about it, is really meant to be kind of a guide for developers as you're going through this process of designing, iterating on, kind of getting your LLM pipelines off the ground, dealing with things like evaluation, tracing, and debugging. Some cool things that we're moving into with some kind of prompt iteration. So we'll talk a little bit about that. You can see some of that on our roadmap. And then really kind of, and like retrieval, search, different pieces as you kind of take these pieces that are kind of key milestones within an LLM pipeline. We see Phoenix as kind of your companion and your guide along the way. So as you look at a lot of things on our roadmap, that's kind of where some of the motivation is coming from behind these kind of things. And our full roadmap, it's linked here. It's also on our GitHub. You can see it all there. It's all public. Some cool things that we're adding in the next few weeks here. First up is annotations. So being able to add human annotations to different spans and traces within the platform. This is kind of I won't say simple because it's kind of hard to create, but it's a somewhat straightforward thing that opens up a lot of capabilities. So things like being able to design evaluators that are like LLMs and judge evaluators that are augmented with human curated examples is a really cool thing that this unlocks for us. And so some folks might have seen some kind of chatter around that as a eval technique. Annotations is what opens that up for us. But a bunch of other use cases that you could use with annotations around kind of manual labeling, human labeling. How do you incorporate that into your flow? Some prompt iteration and kind of prompt playground optimization pieces is another area that we're looking into as well, and should have some updates in the next few weeks. You can see some of that popping up on our roadmap too. Incorporating more information like cost data, token usage. That's another kind of popular request we get a lot of times, is visualizing that, showing that within the platform. We do capture some token information now, but we have a story to beef that up a little bit. So you'll see some of that going forward. So you can kind of keep track of cost use and usage of different LLMs as you're going in. Multimodal support's another very cool one. If you tried multimodal support over the past like week or two with certain models, you might have actually seen this is already in the works in some cases. So with OpenAI direct calls and then Llama Index calls, we are showing images within Phoenix. So we're going to continue building out more multimodal support to kind of beef that up over time. And so we're excited as more things become multimodal, we want to make sure that we're supporting that. And then evaluation model improvements is kind of like a continual thing that we're always going to be thinking about to some degree, is how do we continue to improve the evaluation process? Is there any improvements we can do to the models that are used to evaluate is an area that we're looking into as well. So some of the kind of priorities or immediate term priorities that we have, again, check out our full roadmap. There's a bunch more information there. And then there's kind of the ever present, we want to improve the usability and kind of the day-to-day usage of the platform. If you guys have any feedback, thoughts, anything like that, we really love to hear that. So hop into our community Slack. You can share them there. You can message us directly as well to go through any of those. We love to kind of hear that from the field in terms of people who are actually using the product. Cool. And with that, I'm going to open it up for Q&A. We've got our GitHub here. Also, feel free to hop in there and star us. It means a lot to us as well as we kind of continue to try to grow the product. So with that, we can open it up to some questions. Let me pull up the Q&A that we have here to talk through what some of those are. Let me read these really quickly. Hold on one sec. So one question we got is for Hosted Phoenix around assurances on data privacy. So if data is being persisted, what kind of assurances can we offer around like not training on data or not sharing data, that kind of thing there. I know we are not planning to do any of that. We're not using that data for any kind of training, anything like that. Aparna, I'll let you give more of a detailed answer there as well too.
Yeah, I think Emily, we'll probably do. Sorry if I mispronounced your name, but I think what we'll do is we do this on we'll probably throw up just like a security, data privacy, doc on hosted Phoenix / Llama Trace, so you guys can see kind of what we stand by and what we're going to do. And I think the big trade-off we are seeing for folks here is if you definitely want to host, you definitely want to make sure the data, we just have some teams we work with where the data just can't leave them. There's absolutely always going to be the deploy yourself, host yourself kind of options for Phoenix. But we do have a number of folks in the community who have asked us, well, I don't want to worry about all of that. I just want to get something up and running and get something going. And so it's part of the reason we launched hosted Phoenix. And so, yeah, we are not doing any of that training on it. Your data is not being shared to anyone, but what we'll do is probably just put up a data privacy doc and stuff on the website so you guys can all see what details are.
Yeah, and there's really nothing within our kind of like product or approach or anything like that would need us to train on folks' data. I think even as we're trying to improve evaluation models, there's plenty of publicly available data. There's nothing we really want to take from anybody. So kind of we're aligned with the communities there and leaving that all outside of our access. And then some other ones we're getting here as well too. So there's one on what is the difference between Llama Trace and Hosted Phoenix, and talking through that, because I think folks have seen both those names being used. I can give an answer, and then Aparna, you feel free to add on color as well too. So Hosted Phoenix is our offered kind of like online deployed option that you can access. Llama Trace is kind of powered by Hosted Phoenix, and it's essentially a version of Hosted Phoenix that's accessible through Llama Cloud. It's really the same kind of thing under the hood, but I think we already have a pretty tight integration with Llama Index to be able to instrument and follow all the traces that go through the platform. So it's just a way to have Hosted Phoenix be incorporated into the Llama Cloud ecosystem. And so a lot of the same tech is kind of powering both pieces of it, but I think it's just one that's a little bit more tied in. It's a version of Hosted Phoenix that's more tied into the Llama Index ecosystem. But yeah, Aparna, let me know if I missed anything in there.
Yeah, they're one and the same. We just I think a big part is partnering with Llama Index. We wanted to come up with a cool name for Hosted Phoenix that fit into the ecosystem. So one and the same, everything you're expecting to see on Llama Trace, you'll see on Hosted Phoenix. It's the same underlying tech.
And then we have oh, sorry, go ahead.
I was going to say, there's a question. Oops, I think I started answering with Fernando. We could say he's sent a couple. Maybe I could just make
Yeah.
a quick note on that one.
Mhm.
Fernando, I think honestly, really, really great question on simplifying dependencies on the Python client. I know our team's looking at this. We definitely are. We're definitely looking at this just to make the Phoenix install quicker and lighter. I probably need to dig into the specifics on the SQL dependencies that are specific. So if you're on the community, happy to just get some thoughts or ping you directly and just see if and we can help you out.
Yeah. Yeah, I definitely can grab some time and kind of go through those in a little bit more detail. Um, and then, oh, we got another one coming in here. We have a question around what's the difference between, or what does using guardrails in production application code look like versus running in a notebook as a demo? So like using dynamic data, what does the flow look like to update that data as it's used in the guard in like a deployed production app?
Yeah, great question. So we do have APIs for all of our. I know John we showed a lot of the UI side of it today of being able to create a data set and add examples to a data set, but everything's actually, supported API. I'd even say API first. And so you can actually go and if you see any examples where the guard was triggered, you can go in and add that to your data set. Or if you have any where you're calculating offline uh, and you want to add those over to the guard is into a data set as well, you can do that so that you're doing it in an offline way that's not during the time of inference. But yeah, the flow to updating the data is if you're using the data set embedding guards is to essentially add more data to the data set, add examples to the data set. And then what happens under the hood is we take all of those data points, generate an embedding that represents that data set, and then any new data point that is similar to that embedding will be blocked in a future guard run. So hopefully that answers your question.
Yeah, and correct me if I'm wrong. I think with Phoenix, there would need to be some job that's either using our SDK and then taking out. There's actually an example on the end of that notebook that shows just pulling traces out of Phoenix, adding those to a data set, and you can like query the traces essentially, which will show you like you can pull all the ones that, for example, trip a guard or something like that. And so you could have a job that's then uploading those into a data set and updating a data set with those, or using the API methods that Aparna mentioned. So when we get to production, it looks a little bit more like using that kind of thing. But yeah. And then let's see what other ones we got in here.
I think Lee asked this and I answered, but
Yeah.
just so that others can follow too. It's a really good ask. Is there an example in our docs maybe where the task is just retrieval? I think it's a good one to add. I think I know I know that this is a hot one we've been seeing ourselves, so we can definitely add an example into our docs. You guys can see it.
Yeah, I think we have some that are doing retrieval and then analysis on the retrieval, like it's relevancy of the retrieved documents or something like that. But I think we don't have one that's just focused on retrieval, so that's something we can add in. Awesome. One other one. Yeah,
go ahead.
No,
Fernando asked, are there any examples of production deployments of Phoenix self-hosted? I'm curious, what's the best practices for security, data manage deployment as an API key requirement? Great question, Fernando. Examples of production deployments of Phoenix with the best practices. Okay, so it's a great question. To be honest, I think if John, one of the ones we were highlighting actually in the Phoenix Town Hall from a roadmap perspective, there's definitely maybe we didn't put it here, but I definitely know the team is working on a number of things around authentication. I know this is something that the team's definitely, it's probably in our GitHub board if you take a look at it. But Yeah, on the managed side, what we do have is basically users. We have authentication on the users, and then there's specifically an API key that they have to use when they're um, logging data or logging traces to the doing really anything to the deployment itself. This is a big one that I think what we've been seeing and being asked from the community side of it. So I think what we could do, maybe Fernando, this might be helpful. If you're open to grab some time and we can try to understand your specific deployment and what would be helpful, because we might be able to give some more specific insights from what we're seeing.
Awesome. Yeah, and I think one other piece we didn't really necessarily mention is some of the user support within Hosted Phoenix is another thing that we're working on. So being able to add in and kind of manage users on the same project. So if you wanted to have a single Hosted Phoenix instance that can be accessed by different people on the team, might have some people that are connecting the traces, some people who are then actually creating data sets and using those, kind of unlock some things there. So user access is another big piece that the team is working on with Hosted Phoenix. Awesome. We have time for a couple more here. We have one that's around integrating with other guardrails tools. So whether we are planning to integrate with other guardrails options like Protect AI or something along those lines in addition to guardrails AI.
Yep. Yeah, that's a great question. I'm right now there's so we do have an integration with Guardrails AI specifically. I know we're adding another one next week, which we'll announce. But if there's ones you guys are specifically using or specifically like as a framework, please do let us know. We're happy to add some more integrations and support those frameworks as well.
Yeah, I think those are, it's always nice to hear the tools that folks are using. And I think a lot of them have some sort of instrumentation and things like that we can work off of. So it's always kind of a case by case kind of thing with some of those different platforms. Aparna, are you seeing any that you want to jump in on?
Let me take oh, there's one from Michael. It looks like, please tell me how Phoenix is more helpful than Firebase GenKit for folks developing AI apps. So I'm not as super familiar with Firebase GenKit, so you definitely need to dig in and look into them a little bit more. I think one of the things that I can highlight at least some of the key things on the Phoenix side we've been seeing is super helpful from our product. First off, we're completely LTEL compliant in the way that we actually do all of our instrumentation. And first off, we're also open source in that front. So you can actually go in and look through and dig through all of our code. And I think we really deeply believe that to be able to show that back with the community. Second, so our tracing completely hotel compliant. Our evals library, I also think, is actually probably one of I think our evals library is, we've been using it ourselves and have a number of folks from the community who give us a ton of feedback because they've been using it. But I think some of the reasons our evals library has been really popular is one, it's actually really, really fast. We've done a lot of optimization under the hood to be able to do parallelization, batch up calls. We have explanations supported on all of our evals. There's Rails on the evals so that even if the LLM comes up with a category that you didn't ask it to, it kind of, we do railing on the evals itself. And so a number of things we've actually added to make the evals work both offline and online. So you can use the same framework when you're developing as well as you go into production. And then some of the things that you're seeing around data sets and experiments actually leverage a lot of the stuff that was built out from the the way we do evaluators, the way we actually do the tracing. I think one of the key things also worth highlighting is, with Phoenix, there is also a natural kind of workflow. There's a lot of connections we do have and support to if you eventually do move and want some more of the production side of support. We do have a ton of natural integrations and workflows that work with Arize, so that as you move into production, you can get monitoring of the application and observability, even as the application gets deployed live. So you're kind of living in an ecosystem that has support for both, open source, self-deployment options, development workflows, but then also a pathway into production, really robust production analytics on top of that.
Got it. Awesome. Hopefully that answered your question. I think we probably have time for one more. I see a fun one. When are you adding TypeScript support is one that we've gotten in there as well too. I can take a stab, and then Marna, you feel free to add on as well too. It's an ask we've gotten from a lot of folks over the past few weeks. I think it seems like it's growing in terms of folks who are looking for it. Our existing tracing does work within TypeScript. We have a TypeScript support for tracing within Phoenix now. I think our evals library is just Python at the moment, and so something we are definitely looking at, and we'll hopefully be adding more support for as we go forward.
Let us know if there's some specific things that you're looking for on the TypeScript support side. So like John said, our instrumentation, so for the tracing, is supported on TypeScript. So you can do it either. We have a number of teams actually already using it and giving us thoughts and feedback on it. But we have kind of the auto instrumentation. I'll just drop the docs if you want to take a look at it. But we do have kind of the auto instrumentation, and then we also have kind of a manual, do-it-yourself kind of instrumentation approach also supported. Check it out and let us know if there's anything specifics on that.
Awesome. And on that note, we're right at our time, so we do want to let everybody go. But thank you to everybody for joining. Really fun to kind of go through all these updates. And again, we really love hearing all the feedback from people as you use the product. So please check it out, jump into our Slack, let us know your thoughts as you're going through it. And thank you guys all for joining.
Awesome. Thank you so much, everyone. See ya.
So everybody have a great rest of your day. Bye, everyone.